In section 6.1, number 81, we are asked to graph both these functions, both the function and its inverse, on the same grid, and we'll go dash in a line y equals x. So we'll dash in that one. So we can see how the graphs are related and verify the inverse function relationship using composition. So let's start first by dashing in that line of y equals x. My scale here is each grid is exactly 1 unit, so I'm going right through the diagonals of the grid to get my y equals x line. Probably a little bit lighter than I actually wanted it to be, but it's okay. Okay, and then let's do some different colors here. Let's do f of x in purple. So we can this is linear, and it looks like it's been shifted up 1 unit and magnified by 4. What do I want to do here? Let's go to purple. I'm going to do a little XY table. So x and f of x to plot some points here. So when x is 0, then I put in a 0 here. I get 4 times 0 is 0 plus 1. When x is, oh, I don't know, let's do 2. We get 8 plus 1, so that's 9. And it's a straight line, so 2 points will make a line. So 0, 1, that's 1 point on my line. And 2, 9. Oops, I messed up, didn't I? 0, 1 would be right here. And our 2, 9 would be 1, 2, right about here. So I should be able to get a straight line that goes through those 2 points. Let's see. That would go on forever. And then let's do the inverse. Let's do it in this bright green color. Whoops, wrong thing. Okay. So let's see. Let's do a little XY table for this one. If I plug in 0, I get negative 1/4. Some good things to try actually is to plug in the opposite of that, because I know all my A's and B's are going to flip over that y equals x line. So let's plug in the range from our purple table as a domain for our green table. So let's plug in a 9, I should get a 2 out. If I plug in a 1, I should get a 0 out. So 9 minus 1 is 8, divided by 4 is 2. Good. So let's plot those 3 points. So 0, x is 0, y is 1/4. Negative 1/4, sorry, right here. 9, when x is 9, y is 2. So a point right here, at 9, 2. And a point at x equals 1 and y equals 0. So right here. So I should be able to get a straight line that goes through those. 2 points, 3 points. Whoops, what'd I do? Okay, I think that looks good. And let's see, let's make some observations now. You'll notice that that red line, the dotted y equals x line, it's acting like a mirror to the purple and green line. So the purple is our original function, and it flips over that y equals x line. So each point maps, each AB maps to BA. So we said that this guy was 2, 9, and then we plotted the inverse. When we did the inverse, we found 9, 2, for example. Okay, now our next task is to verify it. Verify this inverse relationship using composition. So I need to find f of x, well, let me just write it because I'm going to stumble over my words here. So we'll do f of f inverse of x. So when I write f of x, instead of the x, I'm going to write in the inverse of x, which in this case is I'm just going to do that in green. So I'm rewriting all my little f inverses. I'm replacing this x right here with f inverse, which is x minus 1 over 4. And when I evaluate that, to get rid of my parentheses first, I do 4 times this. My 4's will cancel, and I'm left with x minus 1 plus 1. And then I can move my parentheses around, so I get x minus 1 plus 1, which equals x. And I need to make sure that's going to be true the other way around too, because the inverse needs to work both ways. They undo each other. So let me just shrink that down to make some space here for my other one. Okay, now let's find it the other way. So I'm going to take f inverse of, and instead of x, I'm going to write the f of x. So f inverse is x minus 1 over 4, but instead of x, I'm going to write f of x. I lost my equal sign there. So that equals f of x minus 1, oops, I'm going to do that according to green, minus 1 over 4. And then evaluating that numerator, I get 4x plus 1 minus 1 gives me just 4x. And the denominator just stays 4, and then that, of course, is x, and that is verified. So that is the inverses are verified with the composition, and you can see on the graphs that they do flip over that y equals x line. They reflect over the y equals x line.